Hi everyone, in last video we have gone through DC shunt motor, and in this video we are going to learn about DC series motor. So in this series motor you will have the series field winding which is connected in series to this armature, while coming to the case of DC shunt motor, these both were connected in parallel, that is in opposite. But in the case of the series motor, the series field and this armature were connected in series to each other. So since they were connected in series, we know that the current flowing remains same whereas voltage get varied, right? So here this in this series field the current flowing is if, and here through the armature the current flowing is ia. But since these were in series, if and ia both were equal, right? So let us suppose that current to be I. Now your field current is equal to your armature current, which is equal to your I. Okay, and here see we have a lot of points to discuss. At last we'll come to know about what are its applications. Okay, so firstly, when there is no load, current will be very less due to the residual flux, right? So whenever there is no load connected, your current will be very less. I mean, what I wanted to say is, here your DC series motor cannot be started without load. There must be a load connected to it. Okay, and see, for this your field resistance should be small. In previous case, that is while coming to the shunt motor, our armature resistance is small, but coming to this series motor, your field resistance should be small, because more current should flow through the armature here. When only the more current flows through the armature, then only we'll get good output, right? So your field resistance should be less because more current should be flown through the armature, and also your number of turns should be less and area of cross section should be more, because in order to increase the armature current, your number of turns should be less, because we know that R is equal to rho L by A, right? Whenever your area is more, your resistance will be small, and whenever your length is less, then only your resistance will be less, right? So since your series field resistance should be smaller, your number of turns should be less and area should be more, which is exactly opposite to that of DC shunt motor. Okay, and here your flux should be less and torque should be like speed should be high. Here flux should be less and speed should be high. Only in that case motor, if the speed is very high and flux is very small, in that case the motor runs at dangerous speed. So that means motor will runs at fast rate. So in order to prevent that, with no load we should not connect this DC series motor. That means without giving any load we should not give connection, because it will dangerously operate at a very high speed. So there must be a load externally connected in the case of this DC series motor, and to prevent that, with no load it should not be operated. And we know that flux is directly proportional to if, right? And we know N is directly proportional to EB by phi already, and here our area should be more. This was discussed already. And when the motor is loading, your flux will be higher and your current will be faster when it is loaded. So as a result your speed gets decreased, because see, we know that flux is directly proportional to current, right? In the case of inductor we have discussed previously that current is directly proportional to this flux and current were in direct relation, right? So when your current increases, that means your flux is increasing. When your flux is increasing, that means your N is nothing but your speed in RPM, right? So whenever your flux is increasing, your N will be decreasing, so speed gets decreases. Okay, When it is loaded, then our speed get decreased. When it is loaded, current will get increased. As a result, speed will get decreased. In that way, we can prevent that motor being running in a dangerously high speed, because running at this extremely high speed can cause damage to the motor, right? And the speed was almost like constant in the previous one, like in shunt motor. And what are the applications in which this DC series motor were used are, it was used in the application which requires high starting torque and variable speed. So wherever you require variable speed and high starting torque, in that case you will use this DC series motor. Whereas wherever you require moderate starting torque and constant speed, you will use shunt motor there. But whenever you require high starting torque and variable speed, in that case you will use DC series motor. For example, in electric traction, like in electrical trains, see, in that electrical train sometimes you require like variable speed and high starting torque is required in order for the movement of that train, right? And also in the case of cranes, and in the case of lifts, which requires a very high starting torque and the variable speed, right? And in the case of hoists, hay dryers, these were used, that is your DC series motor were used. Okay. And now coming to the graphs regarding this DC series motor. So previously we have gone through this relation. See, if you wanted to understand these video clearly, please go and watch my previous two videos which were based on the DC shunt motor, and also on the derivation of the torque equation, because there we have discussed about these formula, that is torque is directly proportional to flux into Ia. So since we know that flux is directly proportional to Ia, right? So as your flux is directly proportional to Ia, we can write flux in the place of flux, we can write Ia again. So Ia into Ia, which leads you Ia square. So the moment you draw the graph between this torque and Ia, you will get it as a like a, how can we say, like a parabola. But since it cannot run at like with zero current, right? If you join this, it means that it is with zero current. But at the zero current, the motor like when the current is less, then the motor will dangerously run at high speed, right? So it should not be made. So just for our convenience, we just put represent it with a dotted line, and your graph will look in this way. Hope you have understood how this graph was in this way. And we know that this N and torque were in inverse relation, right? So if your torque get increased, then your N gets decreased, and that graph looks in this way. And whatever graph you get for N and Ia, the same follows with the N and this torque. So this is how the graph for torque and Ia, this is for your N and Ia. And since here it should not operate without any load, so your graph will be in this way for this N and Ia, and in this way for your N and torque. And this was all about your DC series motor. See, if you want to take a screenshot of this notes, so here is that. Okay, and these were the graphs. And in next video we'll be going to discuss about DC compound motor. Stay tuned for more videos, and if you have any doubts regarding this video, feel free to ask me in comment section. Hope you can understand these graphs by your own, because in the previous video we have gone in a detailed way. So I have just roughly explained here, and if you have any doubt, I'll make a separate video on this. And thank you for watching, and subscribe my channel for more videos only if you like the content. Thank you for watching.